All right, in this video, we're going to take a look at finding the component form of a vector, if you know the magnitude and direction, and also finding the magnitude and direction if you are given the component form, so forwards and backwards. So if we place a vector in the coordinate plane, again, we can put the initial point anywhere we want, but it does make it easier if we start from the origin. So most of the time when we see a vector in component form, it'll be easier if we think of the initial point at the origin, and then that way the terminal point is whatever the x and y, the horizontal and vertical components are of the vector. So here we have vector v, which has the horizontal component x and vertical component y. Just for simplicity, put it in the first quadrant. And we know how to calculate the length or the magnitude of vector v, but we can also calculate the angle at which it rotated. So in that case, it has a horizontal component or an x coordinate and a vertical component or a y coordinate for this point. And if you're thinking this looks a little familiar, hopefully you're thinking trig functions of any angle, where instead of using a magnitude of a vector, we used r for the radius of the circle. So this is just the trig functions of any angle version of for vectors. So instead of r's, we have the magnitude of the vector, but it's pretty much everything else is the same. So again, from trig functions of any angle, we have our magnitude times cosine is x. So in other words, the cosine of theta is x over the magnitude. So multiplying both sides by the magnitude will give us our x coordinate is magnitude times cosine theta. In trig functions of any angle, it was x equals r cosine theta. We're just replacing r with magnitude. Same thing with y. We have the sine of theta is y over r, or in this case, sine of theta is y over the magnitude. So if we multiply both sides by the magnitude, we get y is the magnitude times the sine of the angle. So our component form xy becomes magnitude times cosine and magnitude times sine. And rather than write out this magnitude twice, we have a shorter way of doing that where we kind of, in essence, factor it out. And we have the magnitude times the cosine of the angle and then the sine of the angle. So example 4, find the horizontal and vertical component form of a vector whose magnitude and direction angle are given by the following. We have the magnitude is 12 and the direction angle is 150 degrees. So the x coordinate or the horizontal component is going to be 12 times the cosine of 150, and the y coordinate or the vertical component is going to be 12 times the sine of 150. Well, going back to trig functions of any angle, cosine of 150 degrees is negative square root of 3 over 2. The sine of 150 degrees is a half. So our horizontal component is going to be 12 times negative radical 3 over 2. The 2 divides into 12 6 times, so 6 times negative square root of 3 gives us negative 6 square root of 3, and then 12 times a half is 6. So we have negative 6 square root of 3 and 6, or negative 6 square root of 3i plus 6j would also be acceptable. All right, now we're going to go backwards. We're going to essentially start with our answer and work our way backwards to get the magnitude and the angle of rotation. So this time we're given the vector has component form 3, negative 3 square root of 3. We're going to find the magnitude and then the angle. We're going to restrict the angle just like in before, where we're within one rotation. And we're going to write it in this form. So we don't have to write the magnitude twice in that case. Well, first up for the magnitude, we have 3 squared plus 3 radical 3 squared. Make sure the 3 radical 3 is in parentheses. Also might want to avoid the negative sign again. When we do this, we get 9 plus 3 squared is 9 times 3 is 27. 9 plus 27 is 36, and the square root of 36 is 6. So the magnitude of our vector is 6. Now to find the angle of rotation, we can use reference angles again. The inverse tangent of y over x, and if we ignore our negative sign here, this will be the inverse tangent of the absolute value of square root of 3, and the inverse tangent of square root of 3 is 60 degrees. So the point 3, negative 3, radical 3 is in the fourth quadrant. And if we put a reference angle of 60 degrees in the fourth quadrant, that means our angle would have rotated 360 minus 60 is 300 degrees. So again, we have a x value that's positive, a y value that's negative. We're going to end up in the fourth quadrant where x's are positive and y's are negative. Doing the inverse tangent of square root of 3, again ignoring the negative sign, we get a reference angle of 60 degrees. If we put a reference angle of 60 degrees in the fourth quadrant, that means our total amount that we rotated is 300 degrees, or 5 pi over 6, converting it to radians. Or excuse me, 5 pi over 3, converting it to radians. So we found our magnitude is 12, our angle of rotation is 5 pi over 3, or excuse me, our magnitude is 6, our rotation angle is 5 pi over 3, sorry about that. So we have the magnitude of 6 times the component form cosine 5 pi over 3 and sine of 5 pi over 3. Alright, so that about does it for this video.